Now doing some more tests on the pulse converter. I was finding when the search wheel was being rotated by the motor that the contacts weren't staying closed long enough for there to be a good current flow through all of the contacts. The search contacts back here, and then the write-in contacts, the stepper contacts here. And as a result, that's why the solenoid wasn't closing completely. The pulse was just not long enough in duration. So what I've done as a test is I've broken the circuit to the solenoid here, and I put a piece of paper in this contact of the transfer relay here so the motor won't run, and so I can just run it manually and check to see that I get voltage all the way through the circuit. The DC voltage starts at this gray wire here and then goes through all the contacts, and when it matches up to the desired contacts, it ends up coming out through this wire here, going to the Sprague relay to stop the search process and then write the selection into the memory. So for the first test, we're going to check for the presence of DC voltage through the circuit, and the voltage used here is about 26 volts DC. One more thing I found is that if you look here, the first 3 contacts on the letter wheel and the first 2 on the number wheel are connected together. So when the pulse system starts out, it actually gives 2 dummy pulses on the letters, and then on the numbers it doesn't give any dummies, but it just gives the amount actually required. But I found that I was actually setting the stepper contacts back too far, because I thought that the numbering of the contacts started with the very first one, but the first 2 you can see are actually connected to number 1. So I think I got the contacts in the right place now. Let's see here. Let's reset it here. Okay, we're now reset. So I'm going to write in a selection into the steppers. And looking at the relays here, the first one is the pulse relay. This pulses each time a data pulse is brought in from the keyboard. These 2 relays here are for time delay, and they provide for the time delay between, or they sense the time delay between the letter and number pulse trains. This relay is the transfer relay. This both starts the selection motor and transfers the data stream from the letter stepper to the number stepper. So watch the relays when I write in the selection. You'll first see the pulse relay start to pulse, and then the transfer relay will activate between the pulse trains. So now the write-in cycle has been completed. The data has been pulsed in. What I'm going to do is now rotate the wheel here slowly to see if I can get 26 volts DC through the circuit. And I'm going to keep rotating it here, and I'm not sure why, but when the motor was turning it, it was just flying by. And you see, if it goes too fast, it never builds up. See, if it goes pretty fast, it never builds up to the proper level. It just sort of, but see, it eventually will get up to 26 volts. So now that we have data written in, I'm going to connect the Sprague solenoid back into the circuit with the alligator clip lead here. And I'm going to turn this slowly, and you'll notice the Sprague relay will activate once we reach the point here. And it'll activate fully and reset the selection mechanism. Just got to get it into the right position here. See, that's what it should do. So I'm not sure exactly why it's not able to respond quick enough at the normal speed of the motor. I don't think it will be due to oxidation. I cleaned everything. I may go for a modification here. What I may try to do is to build an amplifier circuit using a transistor that would go from this contact, and it would sense a small amount of voltage, only take a small amount to activate it, and then that would in turn activate the relay, and that would not depend on a high current path flowing through all those contacts. Just a minuscule amount, once it got there, would be able to set it off. So I'm going to try that. I'd ideally like to find out why it's not working as it should, just the way it is. But just as a test, I'm going to try. I'm thinking that may be the best solution. Another solution would be to slow the motor down a little bit so it wouldn't blow by those contacts so fast. But I still want to figure out the real reason as to why it's not making contact like it should, because there eventually is a complete amount of DC voltage, 26 volts, flowing through the contacts, but it just ends up whizzing by in too quick a time. And when the motor is active, I'm gonna activate the motor here, remove the contact from the relay, and you'll see it just kind of may try to pull in, but see, there's just not enough. If you look here, there's no voltage. It's activated the solenoid, it's activated the sprag part of it, but there's not enough voltage there, or there's not enough voltage to keep the relay activated. So now I'm going to put the paper back in there. I'm going to turn it back on here, and since it's not going to move from where it was, it ought to activate as soon as the pulse train finishes. Let's see here. I'm going to try it again here. See, now it's sitting right where it should be. Now, there could still be some alignment problems with these contacts, but just to test, I'm going to try that amplifier route to see if I can make it work. That's not. I haven't still found the ultimate problem, but maybe that will be a workaround so that full current doesn't have to flow through the contacts in order to trip the relay. So I'll try to do some more on this. At least I've figured out what's going on and why the sprag relay isn't activating. So there's part 2 of the pulse converter.